Hi everyone, what is happening? Today we're going to be covering international system. This is the metric system, and we're going to be doing conversions. Now conversions are based on these base units in the international metric system, and all the other units are based off of these. So essentially they're just multiples of our base units. So what we have is we have our base units here. So for length we use a meter. For mass we use a gram in chemistry. Volume we use a liter, and time we use a second. The amount of a substance we have is a mole. We'll be getting into that next chapter. And then a mass for a ton, for a really big amount of stuff, is a T there. And then, oh, I've got volume again, which is a liter. Now, the other units that are based off of these base units are written with prefixes, and they tell us how much of something we have. So giga is a big G, and that means 10 to the exponent of 9. So that means 9 zeros are after that 10. Next we have mega, which is just a little bit smaller, and it's 10 to the exponent of 6. Then we have kilo, which is a K, and it's 10 to the exponent of 3. And this is really important. And now, if I explain this here, what it means is we've got 10 times 10 times 10, and that equals 1,000. So things like kilogram means 1,000 grams. Kilometer equals 1,000 meters. So it's very important. Next we've got deci, which is 10 to the exponent of negative 1. Then we've got centi, which is 10 to the exponent of negative 2. Milli, which is 10 to the exponent of negative 3. Micro, which is a U with a tail, which is 10 to the negative 6. And then we've got nano, which is very small, and is 10 to the exponent of negative 9. Now, let's just see what this means is we have 1 over 10 to the exponent of 9. That's what that negative means. Remember, when we have a negative exponent, it means we take it down and put 1 on top. Now, there's a couple other conversions that we need to know. We've got 1 milliliter equals 1 centimeter cubed. Next, we've also got 1 meter cubed equals 10 to the exponent of 3 liters. So 1,000 liters is in 1 meter cubed. And we also have 1 ton equals 10 to the exponent of 3 kilograms. That's the best part about the metric system. It's all based on tens. So there's some important points about conversions. And this is that we always include our units. Always include our units. Next, we'll always cancel our units. And finally, the most important one, I'm going to put 3 stars right beside this, is prefixes. So this is all these bad boys. Never go beside exponents. And you're going to see what I mean in a minute here. So let's turn down, and we're going to do a couple examples here. So we've got 5 kilograms, and well, we've got our prefix right here, so that's a K. Our unit symbol is right here, and it's a G, and our exponential equivalent, well, what that really means is, what does K mean, or what does K represent as an exponent? So we've got 5 times 10 to the exponent of 3 grams. 10 to the exponent of 3 represents what kilo means, and kilo means 1,000. So what we have there is 5 times 10 to the exponent of 3 grams. Let's try one more. We're going to go 25.2 millimoles. And look what we have here. We've got our prefix, which is milli, and our unit symbol here, which is moles. And our exponential equivalent, so what does milli mean? Well, milli means 10 to the exponent of negative 3. So we're going to go 25.2 times 10 to the exponent of negative 3 moles. And we can rewrite this as 2.52 times 10 to the exponent of negative 2 moles. Alright, I'd like you to try one on your own. I'd like you to tell me what the prefix is, the unit symbol, and the exponential equivalent of 5.1 decigrams. And let's do a couple examples. So we go 5 kg, kilograms, and we're going to get it into grams. So whatever we want goes on top, and whatever we have goes on the bottom so that we can cancel. And let's just write this down. This is what we want, and this is what we have. And then we look on our conversion chart, and 1 always goes with our prefix. It never goes with exponents. Well, what does 1 kilogram mean? Well, it means 10 to the exponent of 3 grams. And we get 5 times 10 to the exponent of 3 grams. And then we're going to cancel, cancel. And we're just left with grams. Let's try one more. We have 46 liters, and we want them into nanoliters. So whatever we want goes on top, and whatever we have goes on the bottom. So then 1 goes with our prefix, and 1 nanoliter, what does nano mean? Nano means 10 to the exponent of negative 9. And so what we're going to do is we're going to get 46 times 1 divided by 10 to the negative 9, and we get 46 times 10 to the exponent of 9. When we divide by a negative exponent, it turns into a positive. And then what we've got nanoliters. Our liters have canceled out. We're left with nanoliters. We can rewrite this as 4.6 times 10 to the exponent of 10 nanoliters. I'd like you to try this one on your own, please. Now, we're going to do some multi-step conversions. The most important rule is we have to ask ourselves what connects the two units. So here we've got centimeters and micrometers. Well, meters connect. So what we're going to do is we're going to go through meters. This is why this is multi-step. So we go 5 centimeters. And what do we want? Well, we want meters, and we have centimeters. We have to put centimeters on the bottom so that we're going to cancel out. And we have 1 go with our prefix. And what does centi mean? It means 10 to the exponent of negative 2. And then we're going to multiply again, so this is why it's multi-step. And we have meters now, so that's going to go on the bottom, and we want micrometers. Our 1 goes with micro, and what does micro mean? It means 10 to the exponent of negative 6. So what we're going to do now is we're going to go 5 times 10 to the exponent of negative 2 divided by 1. Our centimeters cancel out. And then we're going to go 5 times 10 to the negative 2 meters times 1 micrometer divided by 10 to the negative 6. Our meters cancel out, and we're left with 5 times 10 to the exponent of 4 micrometers. Alright, I'd like you to try this one on your own, please. And we will be doing this one in class. And that's our conversions for now. You can try in our textbook, page 21, question 17, A to J. Give it a shot, and we will do the rest in class. Alright, have a good rest of the day.